Next up, we have David and George from Recursive Digital. And they're going to show us some pretty ambitious immersive retail projects. I remember seeing this on the social channels. They're Puma flagship stores in Vegas and New York. And they're very, quite major productions. And basically using Unreal and TouchDesigner to do all of it. So please tell us more. And thank you for joining us.
Thank you. Right, 10 minutes is not a lot of time, so we're going to go really quickly with this. We've got 11, good. Actually, can't even see the screen. Hang on. What's happened here? Bear with me. Display. Okay, right, so this is all about use of TouchDesigner and Unreal in immersive retail. Really, it's a bit of a love story between TouchDesigner and Unreal, because both of these systems belong together. They work fantastically well together. We were lucky enough to do 2 projects for Puma in North America. Both were based on a theme initially, which was called the Puma Arcade. First of all, we did one in New York in 2023, and then we were lucky enough to be invited to expand that in Vegas on Hartley Strip in 2024. Vegas was a significant expansion on what we did in New York. This time we got to play with 3 floors of different interactivity and immersive spaces. The ground floor was an area called the Vegas Zone, and here we built a giant one-armed bandit, which was super fun. So you could go and pull a lever, randomized number of choices. Every now and again you would be a winner, and you actually got a prize, which was quite fun. The second floor, we created a hidden space, which was going to be called the Sneakeasy, but it turns out Nike owned that. So it was a kind of hidden room called the Club 48. Here we worked with the app team to kind of find a way of inviting people to enter the secret space through the app process, opened a door with the help of Raspberry Pi, and then you went in and there was various immersive elements in here, lighting, screens, and so on. And then on the second floor was where we built our new version of the Puma Arcade. This time we got to design the whole thing. We got to build custom arcade machines, neon DMX lighting, soundscapes, interactive floors, many different motion tracking sensors, 3 different games to play. Here's a quick overview of how that looks in the main space. So it's kind of hidden upstairs. You've got a whole anteroom area where you log in, real-time data on tickers. We built all these stickers. We designed the 3D space, various different fun things to happen. And in the main area is where you play the games. So we did all this in 10 months from beginning to end. So it was a really fast, rapid process for us. All 3 floors are solely driven by Unreal and TouchDesigner. And we used all the classic tools, so UDP, OSC, Dante, NDI, ArtNet, MIDI, everything we could possibly find to bring these 2 systems together. And we did a lot of iterative testing. We used VR extensively to visualize how these spaces would look, a lot of physical testing in our studio. So we've got 3 topics to rapidly go through. The first one is the use of data for personalization, which is a really big thing for retail because we want customers to feel like they're having a unique experience every time they come into that store. So we were really keen to look at how can we use data we capture to drive the experience and make it unique every time. And what we focused on is how we can capture information about a person, non-invasive, and start to build a loop so when they return, the store recognizes them and says, "Hi, you're back. Here's where you got to last time, and here's what you can do now." So we start with the game interaction. We capture data, which in our case is a short name, it's a score, it's a series of images. We then generate a QR code from that unique information. They scan that QR code, they go to a microsite, they enter their full name, they can opt into marketing if they want, they put their email, they get an email follow-up, and then when they go back to store, they can scan that. So tip 1 for us is data equals database. It's really easy to think about storing data in lots of different ways. It could be CSV, it could be in tables. We found that Postgres is the way forwards, and particularly using the scicop Python library and TouchDesigner to drive it. Super robust. It's so, so nice in terms of transferring data. Here's a quick snippet. So we've got our kind of classic TouchDesigner table here, which is where we're reading the initial data. Here we get a UUID. This is unique to that person. It comes from the database, from Postgres. We read it in. We generate a unique QR code of that data. We are doing a load of WebSockets to and from the microsite in the background. And we here have returning player data that gets scanned in. Tip 2 for us is TD-pip. This is amazing. If you're not using it, you should be using it. It's absolutely the benchmark of any Python stuff in TouchDesigner. So in terms of what this physically translates to, this is the anteroom. So we've got live tickers, which are streaming your name and information from the database in real time. We've got the arcade machines. This is where you log in and give your data. And we've got Unreal and TouchDesigner running side by side on these. We've got the main arcade space, which is, again, both of these systems. And then we've got an interactive floor and various other bits, which are all in touch. The challenge for this type of system is when you have two systems running, how do you share resources? We need to make sure we can get those resources into both systems. So as a good example, here we've got ArtNet lighting. That is TouchDesigner. It's centralized, ArtNet driven by TouchDesigner, but into a local lighting driver. The main content on the screen is in Unreal, but it's got OSC into Touch because we want the lighting states to change when players enter information. We want the player data to go into the database and back again. And we've got the serial touchscreen going into Unreal. We've got a webcam. The webcam goes into TD, but we need it in Unreal, so we NDI it into Unreal. QR code scanner for returning players, the serial data into TouchDesigner. And we're comparing that to the database. We're returning information back into Unreal. Joystick controller is serial into Unreal, and hidden inside is a single machine, and that's running both Unreal and Touch as one instance. Tip 3 for us is always use TCP IP control power. It's a godsend. So here's an example of the Unreal screen. You can see a mini city. This is a shrunk down version of Vegas. This is your Unreal front end. You enter in a short code. You can choose the game. The states change. And then you'll start that game. And you see in the corner on the screen here the room in the background changing. Inside TouchDesigner, we've now, in gameplay mode, we've captured 3 images across the timeline of your game. Here's our QR code generation. We've overlaid a specific game logo. These become a digital takeaway. NDI is used thoroughly throughout. It is our favorite method of streaming video. It's super versatile. But top tip on NDI is always keep to a standard aspect ratio. Inside the gameplay itself, when the game actually finishes, this is all in Unreal, but actually these images and this QR code are from Touch, and they're being overlaid in real time and distorted to fit this canvas. This is what is actually going on. You've got this texture being displayed in Unreal through NDisplay. The images are coming straight from Touch. The QR code is from Touch, made from that Postgres database, and the whole layer is actually switched on by TouchDesigner streaming that NDI and affecting the alpha layer. And this is what it looks like in the Unreal side, so blank, basically. Here's the microsite. So here's where, when you scan that code, you get taken to the microsite. We've taken that UUID, and it's unique to you. You fill in these details. We send that back to the database again via TouchDesigner. In the background, we're busy making a GIF in Touch, which we will then send to the person. So here's like a little snippet of them playing the game, different shots. There's their QR code. And then here's what they end up with, a digital takeaway from that experience, which is all coming from Touch. When you return, you can scan that code, and the system knows who you are. So it's welcomed you back. You can see your previous scores. You're encouraged to try and beat them. If you do multiple things, you can do other stuff in the store, which is a good reward. Okay, George.
Yeah, so David covered a lot of it. Basically, what we created on the outside is as people are queuing up, they are waiting for the line. Do I just press play? So people can send in messages via OSC and NDI. You can record your message. You can see it at the bottom of the screen. David was recording a short message. That's now my face. So you can send in and encourage your partner inside, your friends. You can send in messages, bonuses, things that influence the gameplay actually, so people can pick up bonuses. This is just a very early prototype of how we created this OSC dialogue between the systems. You can select a bonus that you send in, and the character inside the game can pick it up. And the other side of it is NDI, which David mentioned that we use extensively. So NDI is not only to send in signals and media layers in the game, but also to cover up the loading and unloading of the levels, which can create stutter. So we hide the stutter by overlaying an NDI layer on a unified UI layer. What we see here on the top is that how we actually after some experimentation, we realized that we can comfortably send in one layer only, and with some clever UV maps, that's how we populated all the media layers inside the level. So that means that this is NDI. Every single thing that you see playing back is NDI on one channel. The top of the Fremont Street canopy is NDI, the same channel. All the media layers are the same channel. Every single advert in the whole level is the same channel. So which was super effective because some of the the local networks can't really cope with more than a few channels of NDI. But in this case, we optimized it to it couldn't be better. Here what we see is an early prototype of how the game looked like. It is in our Eastbourne studio. So that's how the game opened up, and that's the cinematic experience that you observe. The sides are actually a material in Unreal. The bottom is the same content projected onto the floor directly through TD. And it's all seamlessly blending, at least at the end it was. What we see here is a mixture of NDI, but in Unreal and in TouchDesigner. So we can't even decide ourselves which part is Unreal and which part is TouchDesigner. We were debating it on the way here. So one part was probably the outskirts of that layer was Unreal, and the insides of that layer of the main game's final chapter was TouchDesigner. So it's really blending in seamlessly.
Okay, last topic is how to keep it all running, which is a massive challenge. For us, TouchDesigner isn't just content creation, it keeps the whole system alive. It's always running in the background. It's a watchdog, it monitors machine health, detects crashes, sends us emails. The aim is to keep this thing running because no one is running this. It runs itself 16 hours a day, 7 days a week. There's no one on site technical. We use all those NDI feeds we looked at to bring cameras into a central monitoring system that we do from London. There's clever tricks you can do, which I'm sure you guys are already aware of, hiding things on screens. So on the left is actually the ticker output. A hidden screen on the right is what we dial into for a TeamViewer, so we can see and monitor and control the system. Here's a good example of Unreal. It's been killed. If it kills, you'll see touch there, hidden in the background. It's counting up, tell us it's actually reset. It's reset it, and it starts it again. So that's within a few seconds. Same with the arcade machines. They will die. Unreal will kick it off. We'll get an email to tell us that's happened, so we can go check. Touch is even watching Touch. So Touch watches itself. So if we kill the main Touch program, Touch will tell us it's killed and start it again, and then we get another email. So overall, all these things come together in a beautiful way, and we highly recommend it. And here's just a quick snippet of New York, the first project. So again, all the motion detections in Touch. This is a combination of Touch and Unreal. All the floor protections Touch. The controls in terms of what's happening in space is all Touch. The projection on the floor is Touch, but the rest of the room is Unreal. And that's it. Thank you very much.
Wow, that's pretty amazing. Oh, wait. Oh, I was going to ask if you could zoom out and show us your presentation.
I can.
Is it just one? Yeah, okay. That's really incredible. Congratulations, beautiful, amazing projects.
I can't, sorry.
No? Okay. Maybe you can play it in open beamers.
I could do.
Okay, great. Any questions? Actually, they're sneaking off. Wait. Okay. Okay, no.
Yes, thank you. Because I thought it's a very complicated infrastructures for the whole process. So I'm very curious about like how did you make this decision of the total like completed procedures like the information infrastructures. Like did you make a decision to use all these things at the first time, or when you're exploring, so like oh I use this one, but this function may not work out, so I need to add this software inside. I'm curious about like the working process.
Yeah, it's a really good question. I think physical testing is the ultimate key for anything like this. You cannot leave it to chance. So we physically tested and built a replica of this, and we ran for everything. So we had early ideas about infrastructure, like the database type to use, how that would work, but we experimented with libraries to see which one would hold up, and we need it to work around the clock so it can't go wrong. And I think we sort of learned through experience of 4 years of doing these types of projects where the best thing is for Unreal and where the best thing is for Touch. Sometimes we have an argument because both sides could do it, but often we try to lean on where the resource is best balanced, because this runs 12 machines at once, so it's a lot to keep going, and we don't want it to get any bigger than that, so we need to be clever about how we split stuff, and that's the beauty of both systems. So you put like your real-time rendering where it makes sense in Unreal, but behind the scenes you're running Touch because it's going to be great with sensors and so on.
Can I just say one thing, that we start testing before the place is being built, so we build everything in VR and we start to test in VR with the actual sensors. So by the time the place is built, we've been testing for like 7 months or something. I think in this case that was key.
Hello, sorry, I have like kind of two questions. One's a little longer than the other. The first one was hardware-wise. Are you running Touch and Unreal on different pieces of hardware? Are you running on the same pieces of hardware?
Sometimes there's just the Touch machine, so TD Brain as we call it, that's doing everything to do with the sensors and the lighting and everything else will be just TD. But often on the arcade machines, it's both. And we're running we're careful to test the resourcing management of that. But yeah, both.
Yeah. So, and my second question was like, I saw like people are kicking the ball at the wall and so on, at the LED wall. Are you guys managing the sensors and everything? And is that just like a dance floor LED kind of thing where you're tracking, or have you got like actual sensors in there?
There's 3 Orbex in there, and we use for the front wall we're using point cloud, slicing in GLSL, rotating, and looking at the ball hits. The rest of the room is on Orbex, plus we've got some webcams that do other tracking. All that is in Touch. It's much better in Touch.
Nice.